Hi everyone. Today we're going to solve one problem. It's called house robbers. We're going to start off by reading the question, and then I'm going to show you a graphical representation of the question and solution, and then we're going to code it. Okay? So let's go at it. You are a professional robber planning to rob a house along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of the house is the adjacent house has a security system connected to it. You see how the words over here has bolded text? It says it will automatically contact the police if two adjacent houses were broken into on the same night. That's a critical information. So if you go through an interview, for example, and someone were to mention these points, they may not highlight it, but they will probably emphasize these very obvious assumptions. I keep repeating on these videos, but it's very important. If someone gives you an assumption, that is probably one of the key elements to that question. Cool. Given a list of non-negative non-integers representing the amount of money of each house, determine the maximum amount of money you can rob without alerting the police. Alright, so I'm going to try something new. We're going to try to explain this question through a graphical representation instead of going through this over here. So let me bring out a Photoshop. Alright, so in this question, what it's really asking is that you're given an array or that represents houses, right? So what you're really given is, say you have a street of houses right here, living in here, boom, 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 etc., etc., etc. And each house has a value to it. So it's gonna be like, this is worth $2, $1, $2, $1, $1, $2, 1, 2, and 1, 2. You get the point, right? So what this really represents is that anything on this element, like if you were to start robbing this particular house, you can't rob the one that's next to you because that's going to alert the police, right? Because it says anything adjacent to your first house that you robbed, then you can't do. So what you could do is you could skip the first one and go to the second element and rob this one, right? And you could do the same, do the third, fourth, etc., right? Or you could skip the first one altogether and start from number 2 and start robbing numbers that are skipping one element, right? So one of the quick things you might think like to do in here is like, oh, maybe I'll just, check, iterate through this array and just check while I skip through one to see if it's a solution, or check the second one and skip and see if it's a solution. Well, there's also a little tiny catch to it. If you also notice that in the question itself, when we look at the examples, let's get that example here. Yeah, if you actually look at the examples, these are very simple examples. They don't really give you too much, right? They still give you the same pattern of, okay, maybe I'll just skip one and boom, I'll get that 4. On this one, they're like, okay, maybe I'll just go and rob number 2, that, and I'll get this number right here, right? But it never really shows you the really edge case I'm going to talk about right now. So the edge case is like, okay, well, what if in this particular case, like, can you guys determine what would be the top pattern to rob to get the maximum money? Well, let's do some really quick representation, right? If you were to go from here to here, and then you skip the house, go here to here, here to here, here to here, well, your sum is only going to be 2, 4, 6, and 7, right? So that's only going to be 7. So it's not going to be your maximum number here, right? But what if you start from 2, boom, 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 boom. On this, well, you're only going to get 1 plus 1, which is 2, and then 4, and then 6 and 8, right? You're only going to get 8. But that is not the maximum money you're going to get, right? The maximum, it's kind of obvious as a human, you'd probably see it as, okay, I'm just going to go from 2, skip here, and then, but over here, well, hold on a minute, I could actually skip 2 houses and get the equivalent value here, but then I get to start robbing this way, and I actually have more money now, which is going to be 2, 4, 6, 8, 10. $10. Well, we did this like visually, but how can we do this programmatically, right? How can we know that, okay, as we go along this particular street, how do we know what our decision is, right? Do we, skip 2 steps, or do we not skip 2 steps, right? So in our question here, it actually asks us to return back the maximum money you can rob, right? It never asked you specifically which house and which index you should rob. So all it asks for is like, what is the maximum money, right? So that's kind of key. By knowing that, that means you don't really need to keep track of position of where you start robbing houses, right? All you really need to keep track of is the actual value. So when we go back into the example here again, all we really need to do is keep track of, like, at a particular position what my my maximum funds would be, right? So if we look at this question, we might think that, okay, what can we do in here that can help us solve this question, right? To get this 10, because I don't think we can start magically iterating to do things and then get this 10 results, because that's not really a common pattern, right? What we probably want to think about is, okay, well, if I go and check every element, does it actually tell me something? Maybe I could start using things that has happened before to help solve the problem moving forward. So what I'm trying to get at is that maybe we could start using the logic about dynamic programming to help us solve this problem. How do I come up with this type of solution? It's because these type of questions really asks about, okay, as you go along a particular step and point in time, you have to make a decision, right? Should I jump 2 steps or should I jump 3 steps, or stuff like that? And that can be predetermined from what you did in the past, right? So what I mean by that is, like, okay, well, if I start at 2, I know for a fact that I can only jump to 2 spaces, or I can jump 3 or 4, but that's what I know. So in position 2, I don't really need to store anything besides just like 2, right? And position this is position 0, this is position 1. So at 1, what do we do? Well, I can't really do anything in the past, so I'm just gonna store my number 1, because that's my, if I were to start at this point, that's my value, right? It's gonna be $1. If I start at this point, I'm gonna start at $2. But when I'm at position 2, what happens here? Well, I could either take the step of going from 2 to 4, making my total being 4, or I could check whether or not, I had some sort of like magic happening, like this one over here. If I could, skip 3 steps or skip another step, and that will give me a higher money, right? So in this one, you're thinking about, okay, I'm going to check my position from here minus 2 steps, because the adjacent one will cause an alarm. I'm going to check whether or not I get the maximum value from, my standard hopping over here, or I'll check the maximum standard hopping over here, right? So in this case, in the second case, this is like invalid, so that won't be my valid choice. In this case, I'm going to go like, okay, 2 and 4. 4 is my maximum. Great. Now I'm going to move on to the next one, right? If I'm looking at in this context, what are my possible jumps that got me to here, right? My possible jumps is if I went from 1 to 1, right? Which will give me a total of, a measly 2. Or maybe I just jump from here to here, which gives me a total of 3, right? That would probably make more sense. So I'm going to make the maximum of maximum of this particular element, which is going to be, we take that 0, that's going to be 1, either 2, or of course 3. I'm of course going to choose 3, right? That's my value here. So when I'm on this step, for example, I'm asking myself the same question. All right, well, over here, I could either take the thing I had before at 4, because, this is sequential, or I could take something that is like 1, right? So 1 plus 4, that equals 5. That seems like a higher number than my 1 plus 1, because that means pretty stupid. I don't want $2. So I'm going to use this and put 5 as my next step. That corresponds to this one, right? So once again, like I said, this is only tracking your total amount of money you've robbed so far. So this is what the dynamic programming is all about. It's about tracking something that you know from your past, right? We know that, for example, when we get to over here, our historical, like this is our total amount at this point in time that we've robbed. It was $4, right? So that's why we keep the number figure $4, right? But when we get into this point, we're thinking about, okay, well, I could have kept that same pattern because I'm skipping this one step and adding here. I'll have myself $5, or I could have just done a skippage and I'll only get a maximum of, $1, which is not that great, right? So therefore, we're gonna keep $5. And let's repeat this pattern. I'm looking at 2, right? Well, 2, we look at whether or not it's gonna be $3, so that's gonna be $5, or 2, you plus the 4, which is $6. So it makes sense that I'm gonna actually make that big jump here. So 2 plus the 4 will give me $6. Cool. Now let's continue on, which is over here. 1 is going to be either $6 or going to be 4. Of course, it's going to be $6. And 2 over here. 2 is going to either be $8 or 7. Right? I'm going to make $8 here. And 1 over here is going to be either 6 or 7, so the same thing. So I'm just going to put 7. And over here is going to be 10 or $8. Of course, I'm going to choose $10, right? So over here, since this is only tracking effectively if I were to do skipping 1 house or skipping 2 house type of thing, we have to keep note that our solution can be any outcome of these 2 elements, right? So our final solution in this case would be this one. However, there is also a possibility that this particular element could have been in our solution, because maybe there was a sequence that we could skip, and this is our last element. We never really get to the last house, right? So we always have to check these 2 elements. So our solution is pretty simple, right? So let me repeat the question again, really, or the solution case is like, as we step through the positions or iterate through each element, we know that we could either start from house number 1 or start from house number 2, right? Starting from house number 3 is kind of dumb, because our only restraint is you can skip 1 house. We're basically leaving free money on the table, right? So you don't want to do that. So a step is either going to start from this or start from that, right? And your third position is pretty much checking, okay, well, if I start from that, then this is automatically going to be 4. So these 3 elements are pretty much set in stone. This is the one when it starts getting interesting, right? Because in here, you can simply have an options. I could skip 1, or I could just jump all the way here, right? Which in this case, if I were to jump all the way here, that's definitely more advantageous than if I were to start in 2 and jump all the way here, right? So that's a good thing. Now let's go into the code and see if we can solve this programmatically. All right, cool. So first thing I like to do is write this in ES6 function again, format. Great. That's just my personal preference. You guys can write whatever you want. You can use arrow functions. You could keep the same thing. That's up to you. So one of the first things that I want to consider is the edge cases that we have to think about. Because what if we're given, because nothing on this question says that we're not going to be given an empty array or an array of size only 2 houses, or a size like that doesn't exist at all, right? So let's deal with those edge cases. So I'm going to check if my nums, that length, is equal to something that just completely doesn't exist. So that one, I'm just going to return 0. My next case I'm going to check is going to be nums.length. This checks the length of the particular array. If that equals to 1, what happens? Well, that's the only house you're going to rob. So I'm going to go and return that value. Return nums at 0, right? Semicolons, forget about those. All right, and the third edge case is, you double check is here. Well, what if your house is, there are only 2 houses on the block, right? Well, if there's 2 houses on the block, then you need to return the maximum of basically position 0, nums at position 0, or nums at position 1, right? Okay, now here's the real fun part, right? How can we start doing this iteration that I mentioned on here, right? How can I do that? So programmatically, it's actually relatively simple. We're actually going to start from the index I equals to 2, right? So for let I equals to 2, right? And I is going to be less than nums.length, and I is plus. Great. Some people might ask, like, why is it I equals to 2? Because JavaScript is kind of fun. This index here is actually going to be 0, right? And this index here is going to be 1, 2, 3, etc. Right? So we're actually going to start from this particular thing, right? All right. So over here, Now there's one of two things you can do. You can actually create an array here, like let array equals to like a cache, like a storage memory place. But I'm gonna try to, this is not good practice. Traditionally, you probably should create another memory space, but not edit the input value. But in this particular case, I kind of want to, just because I like to have fun with that. I'm gonna modify the existing array that's being sent in. So I'm gonna go say nums at position I will equal to the maximum value, math.max, right, of nums at I minus 2, right, plus itself, nums I, or it's going to be the nums at I minus 3 plus nums at I position, right? What's I minus 3? So I minus 3 is kind of interesting when we look at it. Go back in here. I minus 3 here is something that doesn't exist, right? If it doesn't exist, then I'm going to actually just say that, okay, well, I can use this fun syntax here where I just say, I'm going to check whether or not, if that exists. If it doesn't exist, then I'm just going to make a default value of 0, right? This is kind of a little fun trick I like to do. Cool. So what this really does is just taking the maximum value of the one of the value houses that you could buy in the previous or the one just before that, right? That's all you're really doing. And then once you do this, once you iterate, you're going to basically generate this array that I already given you, this particular array, right? And you should get your solution. So right here, you just have to return your solution, that is math.max of pretty much the last two numbers that I mentioned before. That's nums.length minus 1, right? Or it's gonna be your nums at nums length minus 2. All right, cool. So with this, I believe we have the right solution. So let's submit it and see the solution. And great, it's solved. All right, cool. So I tried a different format this time around. If you guys like it, you guys like me going into drawing the solution for you, making it easier to understand, let me know where I can improve. If you like it, subscribe, hit that like button. If there's something I really suck at, please comment below and let me know. I kind of want to engage the audience, and I can tailor the solutions to you. All right, well, thanks. Bye. We'll be right back.